not that scary for those of you who met me. I don't think I'm that scary. So please come by and say hi and have fun in biochem. I guess
so is Friday our final?
Friday is your final.
It's crazy.
I was gonna ask, do you know how to do all the biochem stuff too? Because if you do, I'm gonna need help with that.
I used to teach that class.
Okay, awesome. So you'll be seeing me probably.
I used to teach that class, but it's up to the professor. Like, I mean, I don't know what he's gonna go over. I gave him my notes as to like what I used to go over, and he'll probably do the same thing. I'm not really sure, but he's really nice. He's my neighbor, like my office neighbor.
Oh, I thought it was like your actual neighbor. I was like, oh.
No.
Okay, Jay, what are the odds?
No, my neighbor, my office neighbor. So his office is right next door to mine. All right. Well, so we have our final on Friday. Finals on Friday. So as I mentioned in my like little spiel to you guys, I can't remember when I wrote it. Maybe it was yesterday. I'm not really sure. I told you that I decided to incorporate some short answer. And the whole reason why is because you guys are so much better at short answer than multiple choice. If you look at your exam grades from last time, so I think like in the Dropbox area of where you guys uploaded your short answer portion of your exam, I put your multiple choice score and your short answer score. And you can all see that your short answer scores are much better than your multiple choice scores. The multiple choice on the final is a little bit more generic. As I mentioned, there's a lot of functional group stuff. There's some reactions, there's some naming, but like, oh, what classify this carbon? Is this primary, secondary, tertiary? Those more generalized questions. You have a lot more general questions than specific questions. So based on the performance of exam 2, that's why I want to give you a short answer portion, just to kind of like, I want to make sure that you all do as well as you can. So I will not make the short answer very long. I will post it tomorrow, so that you can have, more than 5 hours to do it. You'll have, somewhere between 20 and 24 hours to complete the exam. So I started writing it a little bit earlier today, and I will finish it either today or tomorrow morning. I will post it. The short answer, so I'm going to write some things here. The short answer will be posted Thursday. Due Friday, let's see, time zone wise, 2:45 in Illinois or 1:45 if you're in Arizona. So pretty much like the end of our class time. The multiple choice, and again, I will put all of this on our D2L page. The multiple choice, there are 50 questions. You have 2 hours of a duration once you enter the exam, but you can only enter the exam between the hours of like when our class starts, 1:30 and 2 o'clock. So you need to enter the exam in this time period, in this time frame of 1:30 to 2 o'clock Illinois time, or if you're in Arizona, 12:30 to 1 p.m.
I have a question.
What's that?
I have a question. So,
yeah,
Is there any way you can make it like, so I noticed, so I guess I thought the exam was going to be like the whole time, like the time frame that we have for our class, but I noticed that it was like only like an hour. Is there any way we can get like the class period time, like the hour and 15?
You will get a total of 2 hours to take this exam.
But when you actually start it,
so once you enter into the exam, you will have a 2-hour block.
Okay, I see.
Is what I'm saying.
So we'll have 2 hours to take the exam.
Correct.
Okay, thank you.
Yes, you're very welcome. But like the exam, to enter into the multiple choice portion of the exam, you will need to enter during this time frame. Once you press start on the exam, you will have a total of 2 hours to complete it. You will not need that much time. I guarantee you, you will not need that much time. But you'll have it just in case that you want it.
Yeah, it's nice just because like then maybe you could like double check your work or something.
Absolutely. I totally agree. So it right now it is set for you to have 120 minutes. Cool. So does anyone have any questions for me right now? Well, if you think of any questions and if you don't want to ask me verbally, you're more than welcome to put it in the chat and I can address it before we leave here today. Please do not forget to upload the problem set. It's due tonight. Just make sure that you get it in so you can get all of those points. All right, well, I will go ahead and address our last functional group. Our last functional group is an amide, and an amide has one of those carbonyl moieties. So this C double bond O, this is a carbonyl, so C double bond O. It is one of those guys, like we've had so many functional groups that have a C double bond O. Now, what makes an amide is that it has an R group on one side, meaning, you know, this R group is some type of carbon-based part. It can be aliphatic, it can be aromatic, it doesn't matter. It just has to be carbon based on one side. And then on the other side, we've got an amine. So this side, a nitrogen is directly connected to the carbonyl carbon. And that's what makes an amide an amide. Now, these things are really important. And the reason why we have to go over this is because you guys will be seeing these in biochem. Like all, you know, our DNA is composed of amide bonds. And so it's generally a reaction from a carboxylic acid and some type of an amine that come together to make this amide compound.
So the blue part is the amide. The pink part is the amine. Is that what, like, so is it both? Or, yeah, maybe I'm confused.
So the whole thing, if we would circle the whole thing, this whole thing is an amide. And so we've got this part, and I'll put this in blue to match right here. So this part is from a carboxylic acid, and the pink part is from an amine. And so when they come together, they form an amide.
Okay, thank you.
You're very welcome. So these things are really important. They're important in biomolecules, and so that's why we have to go over that. Most amides are solids at room temperature, and that's because there's like a lot of hydrogen bonding that can happen. There's some electron moving. We have not been moving electrons in this class, so we don't need to worry about like, this part right here. We don't need to worry about it because we don't push electrons here. But one thing to note is that amides are not bases like amines. Amines are bases, amides are not. But in terms of like, hydrogen bonding, we need to be aware that hydrogen bonding is a thing that amides do. They can hydrogen bond with each other. So from one molecule of an amide to another molecule of an amide, there's some hydrogen bonding that happens. And so it forms this big giant network. These amides can also hydrogen bond with other parts of water. And so it's really important to look at like where the hydrogen bonding is going. So what we know is that we've got this electronegative oxygen. So remember that this means that there is electron density. When something is dense, that means it has mass per unit volume. So if something has more electron density, that means it has more electrons. If something is electropositive, that means it has less electrons. So we've got this electronegative oxygen that is a hydrogen bond acceptor from another hydrogen on another molecule. And this is allowed because this specific hydrogen right here is connected to one of the Fon atoms, fluorine, oxygen, or nitrogen, and it's connected to nitrogen. So this is allowed to happen. This hydrogen is pretty electropositive, so it wants some stability. With all of this, hydrogen bonding network going on, this not only does it make these things solid, but this also increases the boiling point, the melting point, all of that kind of stuff. Because of the hydrogen bonds, this also makes these compounds soluble in water. So because they hydrogen bond with water molecules, they go into solution pretty nicely. We should probably name some things. So since we're deriving things from the carboxylic acids, we can go that route again. So if we want to do that, we want to take a look at the parent carboxylic acid, which is outlined in yellow. So we've got this yellow box, and that yellow box is to say, hey, look at me, looky here, count how many carbons I am. If you were to name this as a carboxylic acid, this should be called ethanoic acid, but this is not a carboxylic acid. We've got the presence of this NH2, which means, hey, this is an amide. So if we want to name this as an amide, we want to get rid of oic acid and add the word amide. So the proper name for this compound is called ethanamide, and it's all one word. So this compound, what's up?
Can you draw the line structures of these two? So, I mean, so I guess like it's easier to look at, these because it's highlighted and all that good stuff. But when you're like taking an exam, it's not highlighted or anything. So,
Yeah, that's right.
so now like you go from the carbonyl carbon, now like how you draw out that line structure, and now what if like the NH2, so I guess like when you move on, like you can explain it. Like if there was more carbons and everything, like maybe draw out the line structure and explain like how you can tell the difference between like the parent chain and the parent compound and all of that stuff.
Sure, yeah, I can definitely do that.
You know what I mean? Like when you draw out the line structure, I feel like it's different. You can see it this way, which like how to name it, but when you are looking at a line structure, I think it's more confusing.
Yeah, yeah. So that's a great suggestion. So this is the line structure of ethanamide, and you can see that I've numbered the carbons. I always label the carbonyl carbon as carbon 1. So we've got carbon 1 here, then carbon 2. And so since this is derived from ethanoic acid, I want to remove that oic acid and add the word amide. So this is ethanamide. I can do the same thing for this second structure over here. It looks like, so I'm going to convert this into a line structure that contains 1, 2, 3 carbons. And when I draw this, I'm starting with my carbonyl carbon to make sure that I get them all in. So we've got 1, 2, 3 carbons. So if you had to name this, a carboxylic acid, what would you name this?
Propanoic acid.
Perfect. You're absolutely right. So this would be called propanoic acid, but this is not propanoic acid because it's an amide. Whoa, I almost called it an amine. Woo! So now we want to add the word amide onto it. And this compound, these are the same thing. This would be called propanamide. We can make things a little bit more difficult and throw some R groups on the nitrogen. Hey, how's it going? Good. You want to do some organic chemistry? Oh, okay. Hi. Have a good day. Thanks. Sorry, I had someone say hi. I'm in a classroom right now, and it's totally dark in here. So it kind of looks funny if someone looks in, because I'm just chilling in the dark. 1, 2, 3. 1, 2, 3. All right, cool. So this is this particular structure. I've got 1, 2, 3 carbons derived here, and then you can see that I have this other carbon that's coming off the nitrogen. I'll put a CH3 here just because maybe it'll be easier to see that way. Now, if we have a substituent on the amide nitrogen, we have to do some other things here. What we need to do is we need to preface the entire name with an italicized N and the substituent that it is. So we call this N-methyl. So this portion of the molecule over here, this is called N-methyl. And that's because the methyl is on the nitrogen.
So if there's something attached to the nitrogen, that's how you know it's a substituent. Because if I were to look at it like that, it just looks like the nitrogen is part of the parent chain. You know what I mean?
Right, so, and it's not.
Okay, so it's just, so it's a substituent if it's coming off of the nitrogen.
Correct.
Okay.
So what's the latter half of the name of this compound?
Is it propanamide?
It sure is.
So the only difference is the N-methyl.
Yes. So you can see how this structure and this structure, how they are similar. The similar part is the left-hand side, like from the carbonyl onward. From the carbonyl onward, it is the same. And the only difference here is what is attached to the nitrogen. We've got a CH3 attached to the nitrogen versus two H's attached to the nitrogen. Okay, let's take a look at the very last one. We've got to number some carbons. So I don't know, like help me out with this. I'm gonna convert this into a line structure, and I would love it if someone could tell me like even one thing about this compound.
It'll be hexanamide.
It'll be hexanamide. It sure will. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Heck yeah, it will. It'll be hexanamide. Yes. And then what else do you think that we're missing here?
N-propyl at the beginning.
Heck yes. Beautiful. This is N-propyl hexanamide. Good job. So 1, 2, 3, 4, 5, and 6. If you're curious of where the hexanamide comes from, it's in green. And then the propyl is the 1, 2, 3 in blue that is attached to the nitrogen. And that's why it is prefaced with that nitrogen.
So,
nice work.
So the rule still applies if it's a substituent. You change like the E or the A and E, whatever, to the YL, like to make it, instead of like propane, it's propyl.
Exactly. Exactly. Okay. Nice work, everyone. Excellent. All right, any questions about that? We good? All right, I take that as a yes. So here's some common amides. Don't worry about the common names. Common names, nope, nope, nope. Let's just follow IUPAC names. This is just to show you that, hey, you know, especially formamide, like formamide is an especially useful amide. So they're everywhere. Now the question is, how can you make an amide? And one of the ways that we can make an amide is through the reaction of very reactive acid chloride. So an acid chloride is super duper reactive. And amines are pretty good bases. Like this is pretty reactive also. Reactive, I'll put a question mark there. And so what's going to happen is that we are going to form an amide bond. So the things that happen here is that we have a bond that breaks between the carbonyl carbon and the chloride of the acid chloride. That is a really fast bond to be broken. And what's going to hook up is one of the portions of the amine. So notice how there's a stoichiometry here, and we absolutely need this stoichiometry because if we didn't have it, it would form HCl, and we do not want to form a strong acid. That would be terrible. So we have another equivalent of the amine that's present to make the corresponding ammonium chloride or alkyl ammonium chloride salt, depending on what the amine is. So I want to please tell me that there's room on the next slide to play.